Welcome to the workshop. We want to begin taking a look at Chapter 2, which is Sets, Relations, and Functions. We'll begin by talking about sets, in particular set operations, Section 2.1. So let's take a look at a quick introduction, and which is just a recollection of the things that we discussed in Section 1.3. So we'll begin there. Of course, a set is simply a collection of objects. Those objects which are in the set are called elements of the set. So we have a few different things. We have the subset relationship. We know what an empty set is. We know when two sets are equal. And then we also want to introduce a little bit of notation as well. So we'll make sure to do that here also. All right. We say that a set A is a subset. Oh, let me change the color here. We say that a set A is a subset of B, and write A is a subset of B if everything in A, if every element is in A is also an element of B. Okay, again, we can phrase it as A is contained in B or B contains A. For the phrase B contains A, it's usually written as B contains A. That sign is flipped. So make sure that you're using the appropriate sign, writing it in the appropriate direction to say what you mean to say. The empty set is the set which contains no elements, and it's denoted by a 0 with a line through it. All right, and then two sets are equal when they contain exactly the same elements. So two sets A and B are equal, and we write A equals B if every element in A is also in B, and every element in B is also in A. So that's the same thing as saying that A is a subset of B, and B is a subset of A. Okay? All right, so let's take a look at a really quick example just to make sure we know what's going on and to introduce a little bit of new notation if we failed to mention it in section 1.3. All right, so is C a subset of B? Well, C is a subset of B if all of the elements in C are also in B. So 2, that's the only thing in C. Is 2 in B? Yes, it is. So this is true. So we're just describing or stating if these if the statements here are true or false. So C is a subset of B. Yes, fantastic. All right, is 2 a subset of A? Well, you might say that 2 is in A, so you'd want to say yes, but it's not, right? This is just a number. If we were to say 2, so this is false. A number cannot be a subset of a set. A set can be a subset, okay? But this is not a set. So if we wanted to fix this, we could write it as 2 as a subset, or as a set is a subset of A. And that's perfectly fine. You'll notice that the other notation for subset is used here, and that matches what's used in the textbook. The other thing that we can do is we could say that, you know, look, 2 is in A. So if we wanted to express that 2 is an element of A, we would write this: 2 belongs to A. We could note, for example, also, just as an additional example, so these are both true, but just to observe something different, we could also say that 3 does not belong to A, right? So we wouldn't say it belongs to, we would say it does not belong to A. So that gives us some additional notation that we may not have already seen. All right, so is the empty set a subset of D? Well, this is a little bit weird. Are there any elements in the empty subset? No, or in the empty set rather. There are no elements in the empty set, so there is no requirement for D to have anything at all. Yes, trivially so. The empty set is a subset of every set. So this is, in fact, true. All right, now let's take a look at this. Is B equal to CD? All right. B is the set 2, 3, 4. C is the set 2, and D is the set 3, 4. So you might want to say that it's true because 2, 3, 4 and 2, 3, 4, they have the same thing, but they don't. They don't actually have the same thing. Okay? B is a set which contains the three numbers 2, 3, 4. This thing is a set which contains the sets C and D. So a set containing numbers is not the same at all as a set that contains sets. So here we have a set of numbers, here we have a set of sets. So this is false. They are not the same thing. And in our next video, we'll see a correction. So we'll see a correction for this shortly. Excellent. So that's all that I wanted to share, was just a quick reminder or a recall of what we had seen in section 1.3. So with that, we'll move forward with set operations in our next video.